Okay, I'm going to go over the Chapter 2 tests that we took in class. Uh, Many of you struggled with this, and I really want you to show units. If you're not showing me units, I'm going to dock you. And so some of you don't know how to show this, and so I'm going to try to do this slowly enough so that you get the idea. We're starting with 5.3 miles, and we've got to get to feet. So this is the only unit on this. Now, the conversion factor comes from how many feet are in a mile or miles in a foot. And we write that as a fraction, and we want the miles to cancel out. So the miles has to be in the denominator. Numerator cancels the denominator. And we have to put feet in the numerator. And from your conversion sheet, you should know that there's 5,280 feet make 1 mile. And now the mile unit cancels. And to get the answer, we're going to take 5.3 times 5,280 divided by 1. And that comes out to be, I could pull out the calculator, but I just want to pull up the answer key so I can just do it. Where did I put that? Over here. Comes out to be, sorry for the hold up here, 27984, and the miles have canceled out, and the only unit left is feet. So there's 27,984 feet in 5.3 miles. Okay, next one. We're starting with 2,845 centimeters squared. That's centimeters times centimeters. That's what makes centimeters squared. Centimeter times centimeter. Now we have to convert this to square meters. So that's meters times meters. So we need to use the relationship between centimeters and meters. And we want the centimeters to cancel and end up with meters. So if this is in the numerator, nothing underneath it, we want centimeters in the denominator to cancel the numerator. And we're going to have to do it twice. And there are 100 centimeters in a meter, 1 meter. That's on your conversion chart. 100 centimeters make 1 meter. So the centimeter unit cancels there. This other centimeter from the centimeter squared cancels this one. And we'll have meters times meters, or meters squared. And so we have to divide this by 100, which moves the decimal place 2 places, and then 100 again, and making it 0.2845 meters times meters. All right. Now this one, some of you just figured it out, but you weren't able to show me how to do it with the units. So I need to see you figure out the units. So if we're going to cover a parking lot that's so many feet, 40 feet by 20 feet, and have a little bit of thickness of gravel, this is a box. And so to find the volume of a box, you take the length, 40 feet, times the width, 20 feet, times the height, 4 inches. But since I'm doing feet and feet, we probably should keep it in feet. So 3 inches is 3/12 of a foot, because there's 12 inches in a foot. So working this out, I would see the 3 and the 12, that reduces to 1/4. So I got to multiply 40 times 20 and divide by 4, or multiply by 3 and then divide by 12. And I get a volume that is 200 feet times feet times feet, or feet cubed. But I need to convert this to cubic yards because they tell me how much a cubic yard weighs. So each one of these feet units has to be converted to yards. And so that's going to happen 3 times. And there are 3 feet making 1 yard, 3 feet making 1 yard, 3 feet making 1 yard. And so the feet cancel, and the feet cancel. And I get 200 times 1 times 1 times 1, 200 feet, yards cubed, yard, divided by 3 times 3 times 3, with no units down here, divided by 3. Well, 200 divided by 3 is, let's see, 3 into 20 is 6. No, 27. 27. 3 times 3 times 3, 27. 200 divided by 27 is, I forgot what I was doing there for a sec, I actually didn't do that. I can do it on a calculator, but I'm just going to write 200 divided by 27 yards cubed, cubic yards. I'm going to write it this way. And then it says that 1 cubic yard is 1.4 tons. So I want the cubic yards to cancel. So 1 cubic yard weighs 1.4 tons. And now the cubic yards cancel, and I'm going to have an answer that's in tons. So I'm going to take 200 times 1.4 divided by 27, and I get 10.37 tons. Now, some of you just did the math and got 10.73 and wrote tons without showing me the units. But this section is about being able to show your units of conversion. So I want to see that. And I'm not going to accept answers that don't show that. So a bicyclist goes 450 meters in 20 seconds, and meters per second is a speed. Now, some of you chose to just write multiply by 3, and by 3, I'll show what that you did, and this became 1350, I believe. 450 and 450 is 900, and plus another 450 is 1350 meters. And then you just wrote 1 hour, but you need to say what this is. This is 60 seconds, or wrote 1 minute. you still need to do a conversion. If you want to do that, you can then say that, see, we want seconds to cancel, so you can put up here and say 60 seconds is 1 minute, and show the seconds canceling and the 60s canceling, and you come up with 1350 meters per minute. It's M's, and the M's are confusing. Probably should use SEC for seconds. SEC, SEC. So this equaled this, and this times this is equal to that, and it's equal to this. These are equal. We're not making up lies, but this is only meters per minute, so we would need still to convert that to kilometers and hours. So 1350 meters per 1 minute we need to convert, need hours, and we want the minutes to cancel. Since they are in the denominator, we need to put 60 minutes in the numerator, which is 1 hour. So these are equal. 60 minutes and 1 hour are the same. And we need to take care of the meters into kilometers. So meters is in the numerator, so we need to put in the denominator meters, and then in numerator kilometers. And there's 1,000 from your conversion chart, meters in 1 kilometer. So now the meters cancel, the minutes cancel, and we'll have units that are left of kilometers per hour. And we're going to take 1350 times 6 divided by 1,000, and you end up with 81 kilometers per hour. Now, instead of doing this 3 at the beginning, I expected you just to go 450 meters in 20 seconds. We need to get kilometers, and so we put meters down in the bottom to cancel them, and kilometers match up. There's 1 kilometer is 1,000 meters. That would take us straight to kilometers per second, and then we need to get the seconds out of here, so we can go seconds and hours. And there's 3,600 seconds in 1 hour. So the seconds cancel and the meters cancel. And we're going to be doing 450 times 3,600 divided by 1,000. And that also comes out to be the 81 kilometers per hour. B. If they're burning 300 capital calories, that's kilocalories, per 1 hour, and a watt from your worksheet is joules per second. To figure out the watts, we have to convert calories to joules, an hour to seconds. So we're going to do a capital calorie is, you can look in your conversion chart and it tells you how many joules a capital calorie is. And 1 capital calorie is 4,180 joules. Or you could convert this to small calories, 1,000 calories, make a capital calorie. Then we'd be in small calories, and then you can use a conversion for that. 1 small calorie is 4.2 or 4.18 joules. And that converts capital calories to joules. 300 times 1,000 times 4.18. But that would be joules per hour left as units. We need to get the hours out of there. And so we can put 1 hour in the numerator so that the hours cancel, and use what is equivalent to that in seconds that we need. 3,600 seconds make an hour. And then our final units would be joules per second. And we take 300 times this times 1,000 divided by 3,600. And we end up with 350 joules per second. And every joule per second is a watt, so we get 350 watts. So some of you had trouble with this page, a lot of trouble with this page. Hopefully that helps. Now let's go to the next page. Most of you converted this to a mixed number, which is just fine. So 1 is 3/3 plus 2/3 is 5/3. And parentheses like this mean times. And 2 is 4/2 plus 1/2 is 5/2. And to multiply, you multiply straight across, you get 25 over 3 times 2 is 6. And that would have been an acceptable answer. Some of you changed it to 6 goes into 25, 4, with 1 left over and 1/6. Now you could have done it this way. 1 plus 2/3 times 2 plus 1/2. So 1 times 2 is 2. 1 times 1/2 is 1/2. 2/3 times 2 is 4/3. And 2/3 times 1/2 is 2/6. And we just have to add these up and we'll have this answer. Now 2/6 is the same as 1/3. So that makes 4/3 changes to 5/3. So we'd have 2 plus 1/2 plus 5/3. 5/3 is 1 and 2/3, so we'd have 3 plus 1/2 plus 1/3, or 2/3. We could do it that way, or we can change these to common denominator 6. 2 plus 3, 6 plus 10/6, which is 2 plus 13/6. And 6 goes in there twice. So we'd get 2 plus 2 plus 1 left over, 6. So that's 4 and 1/6. That's a lot more work, but you could do it that way. Sometimes the problems are easier to do that way, and sometimes they're easier to do this way. This one, 2/3 minus 1/4. They're in parentheses, so you have to do that first. There's 1/2 divided by, what's this going to be? Well, the common denominator is 12, so we multiply by 4 and we get 8/12 minus, multiply by 3 and we get 3/12. So we have 1/2 divided by 8 minus 3 is 5. twelfths. And the rules you've learned for this are 1/2 times 12 fifths, which is 1 times 12 is 12. 2 times 5 is 10. If you reduce it, it's 6/5. Or if you want 1 1/5. Any of those three would have been an acceptable answer for me. Number 5. How many milligrams are in this many kilograms? So we're starting with this. Just that number, 0.00034 kilograms. Nothing with it. We need to get rid of kilograms and get closer to milligrams. And our conversion table had grams and kilograms matched up. There was 1,000 grams in 1 kilogram. The kilograms cancel. We are now in grams, but we're supposed to go to milligrams. And our conversion table tells us that 1 gram is 1,000 milligrams. And now we would have it in milligrams, the only unit left. So we have to multiply this by 1,000, which moves the decimal to here, 0.34, and then multiply again by 1,000, which should move it to 340 milligrams. I'm looking for showing the unit of conversion. Now you could have done this one 0.00034, and if you knew that there was 1,000,000, 1,000 milligrams in 1 kilogram, and the kilograms on this would cancel right away, and we'd get 1,000,000 times this, which is 340, and the units would have been milligrams. Okay, 1 second. Okay. 4% of the mass of a beverage is alcohol. And a person is estimated 3 liters of blood drinks 250 grams of a beverage. So if they drink 250 grams and 4% of it is alcohol, so 4 parts out of 100 parts is alcohol, this will tell me how many grams of alcohol. So I take this times 4 and divide it by 1,000. That comes out to be 10 grams of 10 grams. I said 10 and wrote 100. 10 grams of alcohol. Now, if all of that goes into the bloodstream in an hour, so you've got 10 grams of alcohol in the 3 liters of blood. But you need to know that blood alcohol content is, the units are grams per 100 milliliters. So this would be 10 grams. We need to convert this liters, so we need to get the liters out. And 1 liter is 1,000 milliliters. So that would convert the liters, and so we have 10 grams per 3 times 1,000, 3,000 milliliters. But the blood alcohol is done by how many grams are there in 100 milliliters. So we need to change this to 100. And so if we take 3,000 and divide it by 30, multiply it by 1/30th, divide by 30, and do the same to the numerator, the 30 reduces that to 100. And so now we've got 100 milliliters, and we have 10 times 1 over 30 is 10/30ths, which reduces to 1/3. And the decimal for 1/3, well, we'll just write 1/3 of a gram of alcohol for every 100 milliliters of blood. So if you change that to decimal, you'll get the blood alcohol content, because we've got how many grams in 100 milliliters. And 1/3 is 0.33 repeating, and that would be the blood alcohol content factor, because it's 0.33 grams per every 100 milliliters. So that's how that works. Okay, next page. It said the area of Antarctica is 14 million. And some of you didn't use the million. 14 million kilometers squared. And it has an average depth of 2.15 kilometers. So if you multiply the area times the height, you get the volume of the ice. Then ice, when it melts, shrinks. So the shrink factor is 5/6, which they said here. So the volume of water we're going to get in cubic kilometers is going to be 14 million times 2.15 times 5 divided by 6, which comes out to be here 25 million and 80,000 kilometers cubed of water. That'll spread over the entire globe, or at least the water areas of the globe, and raise the sea level. And that was a problem that you were supposed to have in your melting project, so you should have done that one. Now we played a game where you had to move 4 red chips and 4 yellow chips to get to the other side. Now I said, what would be the least number of moves for 3? And in class we did this. One of the things we did was to simplify the problem. So that's at one of the couple of things. And we did it with just 2 chips. So we moved 1 here, jumped, and then moved it, and took 3 moves. And then we made it more complicated, did it with 2 on each side with a 5 space board, moved 1 over, jumped, and then brought this one up so that it's alternating, jumped and jumped, moved that one over, and let's see here. So we got to I'll mark it here. There's 2 here and 2 here. So the first, I'll just put an X there. X, blank, X, and 0, 0. Second move it O over, 0, blank, X, O, X. Move the O over, blank, X, O, X. Now I'm going to move the X over. That would leave the blank here, 0x. Then move the X to there, so I'm going to have X, O, X, O with a blank. Then I'm going to move the O over. And then I'm going to move the jump with the O, so I'm going to have X, blank, X, O, O. And then I'm going to move the X over, and it's going to be X, X, blank, O, O. So took 1, 2, 3, 4, 5, 6, 7, 8 moves. And the pattern was, if you remembered, I said it was 4 squared, or 2 squared, 2 squared, which makes 4, minus 1. This was 3 squared, which is 9, minus 1 is the 8. And so for another couple, it's 4 squared minus 1, which was 15 moves. The one we did in class was 5 squared minus 1, which is 24 moves with 4. Or it was 3, went up by 5, it was 8, went up by 7, it was 15, went up by 9, 24. So first we simplified, then we looked for a pattern. I would like you to write that out. Looked for a pattern. Simplify the problem. I'm drawing a picture, so that's another one we did. A diagram or a picture. And we can use the manipulatives. We actually use the chips to make it easier to move them around and try it. And sometimes you just need to take a break. That's another problem solving. Take a break, think about it, not think about it for a little bit, and then come back to it. So those are things you could have put for there. And so we just now mentioned 3 of them. Look for patterns, draw a picture, simplify the problem, make a diagram, and take a break. And there's other things that were in the book, okay? And this one, I just did that one on another video on the problem set. This is where I got this one, from the problem set on 2C. So take a look at those videos and you can see how to do that one. And that's it.